This is section 4.7. One example, find the dimensions of a rectangle with area 1,000 square meters, whose perimeter is as small as possible. So in this problem, we want to minimize the perimeter. So the first thing you might want to do is you want to draw a diagram. So I'm going to draw a rectangle. And of course, we need the variables, so let's call x and y. Okay, so what's given? The area is given, so we know the area is length times width. So in this case, it's going to be x times y equals 1,000. Now, don't forget, we want to minimize the perimeter. So the area is given just for us to solve for one variable. So you don't want to keep two variables. You want to make it one variable. So I'm just going to solve for y. 1,000 divided by x. Okay. So we don't care about the area. All we care about is the perimeter. Now the perimeter is 2x plus 2y. That's the formula for perimeter. In this case, y is 1,000 over x. So I'm just gonna replace it to x plus 2 times 1,000 over x. All right, so we want to minimize the perimeter. We need to find the critical numbers. Find the critical numbers. Okay, so in order for us to find the critical numbers, you need to take the derivative and set it equal to 0, or find the values where the derivative does not exist. So let's take the derivative. In this case, is the derivative of the perimeter, so p prime of x. It's going to be 2 minus 2,000 over x squared. Okay, so hopefully by now you know how to take the derivative really well. Now, you want to set it equal to 0 and solve for x. So in this case, I can just find the LCD. I can factor it. So if I get the LCD, I get 2x squared over x squared minus 2,000 over x squared. So I want to factor it out. Minus 1,000. The reason I want to factor it, so I can just set it equal to 0. So as you can see, if x squared minus 1,000 equal to 0, then we have the critical numbers. If this one is undefined, then we also have a critical number. However, in order to make it undefined, x equal to 0. But we do not want x to be 0. X has to be positive, right? Okay, why is that? Let's face it, it's the length. The length cannot be 0. If the length is 0, you multiply, there's no way you can get 1,000 for the area. So x cannot be 0, y cannot be 0. Okay, so the only critical number that we have is going to be, if I take x squared minus 1,000, set it equal to 0, x is going to be square root of 1,000. Of course, we don't want negative square root of 1,000 because, like I mentioned earlier, x has to be positive. So that's the critical numbers. Now let's take the second derivative because we want to check for concavity. So for concavity, right here, I'm going to take p double prime of x. And then you want to take the derivative. So is going to be 4,000 over x cubed. Okay. So we mentioned earlier x is greater than 0. Therefore, 4,000 over x cubed have to be greater than 0. So let me just rewrite p double prime is greater than 0. Therefore, we have p is concave upward throughout its domain. Okay. So now we want to evaluate p of square root of 1,000. Okay. So what's that? 2 square root of 1,000 plus 2,000 over square root of 1,000. Okay. All right. So if you rationalize this, you're going to end up with 4 square root of 1,000. Okay. So this point is an absolute minimum values. Okay. So now we know the dimension is going to be x equals y equals square root of 1,000. So if you want to simplify it, we can take 10 out. So it's going to be 10 square root of 10 meter. And we're done. So this rectangle, in fact, is a square. So it's a square because x equals to y.